now.
Yeah.
So how has that worked? Has it been sort of few in the office or office directives?
So
we'll still have some people in the office. So
Monday and Tuesdays it's a lot of people. Then it's really crowded, and then people start more and more working from home the rest of the week. But it's even that has been increasing.
Yeah.
Cool. Welcome here, Luka.
Thank you.
I just came and had a talk, one of my traditional inspiration of AI kind of talks, and I always end those talks with one and the same type of slides, and that is how to make AI learn to dance. And this is from a project that you did with your wife, if I'm correct.
Correct.
So can you please just give a quick background? What's this? How can you make AI learn to dance?
So it started by me going off and evangelizing the greatness of AI and everything AI to my wife, and how it was applicable to just everything. And she was slightly skeptical, but said, "Okay, but how would you apply this to dance?" Then I thought a bit, and what we did was that we recorded a number of hours of her doing her choreographies, dancing with choreographies.
She was a professional dancer, right? Or
Yes. So she's a choreographer, but former professional dancer. And we recorded with a Kinect sensor that basically captures the joints of the body, so you get like this moving stick figure.
Standard like Xbox Kinect sensor
Yes,
thing?
exactly.
Yeah.
Captured data from that, like time series. So it's, if I recall correctly, it tracks 25 joints and 3...
27.
20,
yeah, 27 I think.
27.
Very important that it's 27.
You probably are correct. It's probably 25 then.
Somewhere between 25 and 27 joints. And trained the neural net to generate new choreographies, and it worked. So we wrote a paper on it, published it, and recorded a couple of videos. And actually, she's doing research. She continued with the sort of AI and dance research. So she's now at Stockholm's Konstnärliga högskola, exploring various things like style transfer, also now the different text generation things, and see how it works together. Yeah.
And just to make all the techie people listening in happy as well, they are not happy right now because you said, it worked. We simply learned AI to dance. But if you were to go a bit deeper into how did you make it work, what was the solution, so to speak?
So it was relatively straightforward. It's an LSTM. What was not super simple was the error function, because if you use mean square error, it just converges to a single point, like a single pose, and won't move around.
Some node collapse happening or something.
So we used MDN as a metric, and it's basically a way of making a discrete space out of the...
So mixture density network? Right?
Yes, exactly. So I thought it was for techies. I mean, everybody knows what an MDN is.
I don't think so, actually. But
so this is the cool thing. So there are techie perspectives, and there are people listening and needing to know that doesn't follow at all. But I think one of the things we have talked about is that actually exposing everybody to talking about the real techie stuff, but then maybe explaining it together, dumbing it down. That's my job. It's really cool. It's a good way to really get your, demystify and get really immersed in this topic. Cool.
But it is a problem, I guess, to learn, 27 or 25 different joint position in a 3D world at the same time, right? And a single model to predict them all, right?
Yes. So to reduce the space so that it wouldn't be 27, because it turns out, and we actually had a master student at Peltarion investigating this. Basically, for some reason, the mixture density model can only handle a few dimensions. After that, you sort of get all sorts of problems. So what we did was that we used an autoencoder first to reduce the dimensionality. So the 25 to 27
was reduced down.
Joins to 5 or 6 or something like that.
Yeah, and it's times 3 because it's the 3D coordinate, right? For everything as well. So
exactly.
Yeah, I mean, I'm always impressed when I see that, and I usually start with showing after 10 minutes of training, it just randomly is moving around. But then after it's been trained for 2 days, I think 48 hours.
It was a weak computer back then.
Okay, yeah, probably today computers it would be faster, but still you can see the AI like a, what do you call it, like streckgubbe, like
the stick figure.
Stick, yeah, is actually making dance move in a generative fashion. So basically taking step by step continuously and can do so forever.
Yeah.
And it looks really cool. And it's really, you can see it's in the style of the human dancer. So it's learned that type of dance. What was the name of the dance? Was it professional?
Like jazz
dance? Modern dance?
Contemporary dance. Modern.
It's one of my favorite way to end a talk, and everyone gets super, excited when.
So you have
when
a little video clip or something.
Yes, exactly.
Yeah.
So cool.
It's, one interesting thing regarding that was I use that clip a lot as well to show, and like the crowd pleaser at the end of a presentation.
Yeah.
And like 3 years ago or so when we did that was sort of after a talk. That was what people wanted to talk to me about, and what they remembered. It's a dance guy. And the interesting thing there was the shift, because then AI, sort of almost any audience that you talk to, especially in the sort of enterprise space, it was like, oh, this is awesome new technology. It's none of our problem now, but it's cool how the future looks. And then it rapidly shifted when it was like, cool dance figure, but this use case and this use case, and how do I implement this in my organization? So there was a massive shift from like, oh, cool technology to like, how do I do this?
2 years ago, 3 years ago, when was the shift, you say? Or has it been gradual?
I would say, 2 years ago, I think the sort of really noticeable shift was.
So we're not talking anymore that why we need to do it. It's more like, okay, how do we do it?
Yeah.
Or what should we focus on?
Absolutely.
Good.
Cool. And let's just backtrack a bit and see, for people that don't know you, who are Luka?
So,
who is Luka?
Yeah.
I'm the co-founder and the CEO of Peltarion, Swedish AI company that creates a platform that makes it possible for non-data scientists and non-AI experts to build advanced AI systems and put them into production.
And I think we can speak more about Peltarion later and the vision and the reason for you starting the company. But perhaps a bit more about you as a person. You went to KTH, right, before?
So I studied electrical engineering together with Måns, my co-founder. And we were originally drinking buddies rather than professional buddies.
As everyone in university, I guess.
So then towards like it was the third or fourth year, we started getting interested in AI. Actually, my first encounter with AI, with neural nets, was when I was in high school, and I had this like Windows neural network simulator, which was a.
So that's a Windows operating system, you mean? Some kind of simulator on it?
It's a simulator on it. And it looked like it was like a window, and on it had a lot of boxes, like text boxes, and there were some random numbers in it. And I didn't understand anything of it. So that was my first contact with neural networks. Then I deviated a bit, and for like my, what's it called, exam project in high school.
Thesis project.
Thesis project in high school, I did a chatbot.
Really?
Yeah.
That's an interesting story by itself, but okay.
So
what year is this? You remember?
This must have been 97.
Early chatbot.
Yeah, and basically what it did, it had a library of answers that were keyword triggered, and then it had a grammar engine that tried to make something sensible out of the sort of sentence when it didn't occur in the sort of keyword hit list.
It sounds unfortunately how chatbots work still today in some way.
Yes.
Okay, cool. So you, was it during your studies that you started to have a passion for neural networks? I know that you had a passion for that long before even deep learning happened.
Yes. So I think it was like not in the last year, but like towards the end of the education, I had a couple of AI courses. and both me and Måns were fascinated by the concept of the computer programming itself.
Right.
So we tried a bunch of things. Neural nets was one. Another was genetic algorithms in various fashions. So we had one of the naive ideas that we had was like, hey, evolution can build these really awesome things. Why can't we just generate the programs, generate it sort of bit by bit? Of course, the computing power wasn't anywhere near that, and still isn't anywhere near to be able to do that. But then we sort of got more into neural nets, and we started the company while we were still at university, and sort of made our product as part of our thesis project.
All right. Okay, so your thesis project was about some kind of tooling for
So
AI,
it was, I think the title was Neural Network Applications in Classical Mechanics, but that was just a cover so that we could in peace sit and develop our...
And what was your initial business or product idea at that point in time?
So what we saw was that neural networks are awesome, but they seem to be confined just to academia. And those people in academia, they seem to enjoy it a lot, that this was this esoteric secret science that people were doing. So we thought like we should simplify this. We should make this much more user-friendly so that it could be applied to real-world problems. So in many ways, what we did back then is the first iteration of what we are doing now. Now, of course, technology has changed, user base has changed, and so on. So there are differences. But the core idea of having a simple user interface to be able to build neural networks and deploy them.
That's the basic first principle idea
exactly.
here.
Mm-hmm. And then I would say possibly sort of the strongest, are sort of where we invest most time there was building this big pre-processing and visualization engine.
So you started to build some kind of product or tooling or
So
development environment, or how would you call it?
We call it a development environment.
Yeah.
It was sort of inspired by Microsoft Visual Studio, but it was fully graphical. We could import your data, visualize it in various ways, then build a model, train it, and then put it into production and analyze and things like that.
And that was like a desktop application at that point?
Yes, that was a Windows-based desktop applications. This was before GPUs and so.
So what are we talking here? When did you go? When did you graduate?
2004.
2004.
Right.
What were you doing 2004?
My PhD, I guess.
You were in PhD, and I was right about moving to Australia to work and surf.
Yeah, cool. That's a long time ago, but still, yeah.
Not that long, but it feels a long time ago.
Yeah.
Oh, actually, it is a long time ago. 16 years.
No, but I remember the first time I saw Synapse, which became the name, I guess, at a later point in time. How did the name come about, so to speak, for that?
I think I saw a movie with Tim Burton that had this super conspiration thing that was this software that's going to take over the world that was called Synapse. I think the original, the sort of first name that we had before release was iStudio, like Intelligent Studio, but I was like,
cheesy.
Cheesy, yeah. So
like name.
Synapse is cool.
Yeah,
not
I
bad,
think so
not
too.
bad.
There's another Swedish company called that, I think now.
Is it now? Of course it is.
There's also Microsoft Database that they just call it. Very confusing.
Very confusing.
True. Okay, so you started to build this tool, and if you were to just very, very briefly describe what was the functionality of Synapse, how would you describe it?
So you could import data from a number of sources. It was built entirely plugin based.
Yeah.
So every part of it you could add to by just writing a new plugin. So you would import your data. You had a number of formats, and then you had the whole pipeline for pre-processing and visualization and data mining. So you could add filters and pre-process your data, and then you got your data to the model builder part of the app, where you could construct a neural net.
And you use the term like filters, etc. Was it intentionally like from Photoshop kind of terminology kind of thing, or?
Exactly. So it was we basically got the idea from Photoshop to have non-destructive filtering where you do modifications to the data, either on a sample basis or a feature basis, and that you could basically rearrange them and remove without touching the data. And then when you ultimately sort of applied it, when it went into the model, and also then when you deployed the model, then you will get the filter stack there deployed.
Right. So it's coupled with the model in some way.
Yeah.
And when did you pick up sort of your programming skill or software skills? Is that at university, or is it something you've been doing also? Hacking the
much
whole
earlier.
Yeah,
I think
hacker by birth.
Never hacker fully. Never sort of the demos scene
No.
and so on. It was more on a. So I think my first software that I remember that I wrote, that I was perhaps 10, 11 years old, and I had this. Me and my friend, we had the same type of parrot as a pet, and I wrote some software that was basically an instruction book for keeping the parrots in a log that you could do things. So it was really.
So
simple
what are we
stuff.
talking now? Commodore 64.
So it was in parallel. So Commodore 64 was one, and then this was on some like QBasic on 286 PC.
PC.
Yeah.
Because I think this is pretty cool. I mean, like, I have three kids, like 14, 12, and 10, and I think we have I've picked up that my middle kid I think he has an aptitude and interest for engineering and software and stuff like that. But right now he gets sort of completely bogged down in playing Minecraft. So, and we are trying to sort of get him inspired. You know, why don't you try write some code, or why don't you go to these classes? So he went to one of these courses, something like Höstlovs education at Tekniska Museet, and I think he kind of loved it, but he doesn't sort of get into it, right? So we try to give him a computer. What was the triggering fact, sort of getting mesmerized by computing or writing software? Not all kids do that. More kids should do it, I guess.
I don't remember, but what I sort of, for me, what coding is and what I'm missing today when I don't, is the creativity of it. That you can create something and you can see the results rather immediately. Cool. So it's for me, it's always been like a creative kick.
Yeah, very cool.
And then Synapse, you could import your data, you could do the filtering, some kind of pre-processing, and you could train some models. And I guess that was not only neural networks, right? You did support some other stuff?
We also had support for trees, also some more obscure things like fuzzy logic. And it's all a tree graph anyway. So and things that are not, which I'm just basically waiting for it to come in new editions, but like self-organizing maps, neural gases, and things like that.
And I know you're a bit humble here, so you don't want to say all the people that used it, but people can Google for this later. But it was a lot of companies that made use of it, and a lot of research papers that were written making use of Synapse, right, during that time. Yeah. And a lot of like NASA and Tesla and whatnot that actually made use of that in some way, right?
Yes. It was interesting. We were completely flying blind. So our sort of whole go-to-market idea was, the internet is big. So if we put out some ads, I mean, the internet is so huge that's like people will come and this will become a global big giant. And then what we weren't aware of was that we were in this period today known as the AI winter, or the second day.
No one told you about the AI winter.
No. And when we realized that, then we tried to cover things up a bit. So we never said. We censored away neural nets, and we called it adaptive systems and things like that.
Oh, so it was uncool.
Yeah, it was very uncool.
Yeah. That's funny. You were riding the opposite hype train. I love it.
No, I remember when this must have been like in 2006 or 2007. We were at one of these conferences that are now huge.
NIPS, Ishkai.
It could have been NIPS, or was it ICANN? So one of the sort of neural network specific conferences, which was like amazing for like meeting people who knew what backpropagation was. Like, it was like, whoa. like this tiny.
Yeah. Sorry. But then the years went on, and you worked for that for some time. But then something happened in 2015, 16 or something. Right?
So basically, I would say what made this work? What made this work commercially? It's like, okay, we sold these licenses over the internet, and in the end, we did have some 300 customers and sort of 10,000 users overall. But it alone, especially in the early days, would have barely paid for me and Måns for our salaries. But what made it possible is that we worked with some companies. One of the early things that we did was a house prediction model. So this company that back then had the monopoly in Sweden, so all of the banks used them for doing house valuation. So when you take out the loan for a house, then they want to know if it's really valuable or not. Yeah. And basically, what they had a model in place that was like built on theory rather than on data. And they were like, they gave a valuation, and then there was a confidence interval that they got. And then the first thing we did was measure it and so like, you're giving it out with a 40% confidence interval. So there's a larger chance of the prediction being outside of the range than inside of the range. So we built a prediction system there, and also, there we learned a lot on sort of putting stuff into production and the importance of the things there. But that sort of kick-started us.
Yeah.
Sort of
and just to explain from a more techie point of view, how do you predict the value of a house? What type of data do you use, and type of model were used, etc.?
So this is pre-deep learning, so it's still neural net. So it's a feed-forward backprop neural net. In fact, it was a construction, the best models that we have that Måns invented, that was called fully forward connected perceptron array. I remember it.
Awesome.
I mean, like, you need to get extra points for cool names.
Yes,
right?
yes. So
is that an acronym now as well? FFPCN. I forgot that. We always call it the acronym, but apparently I could just remember the full name now. That's funny.
So, but it was basically a network. It was 6 or 7 layers deep, where each layer had a lateral connection to the next layer and to the last layer.
Skip connection, basically.
Yeah, or was it to each layer? It was fully forward connected. Then it's probably that each layer had to all of the other layers.
I can understand. Okay, cool.
And so that was the sort of the basic model, but feed forward neural net.
And if you take it in layman's terms, so I can follow, like what's the input data that you know, and what is the prediction? So
basically, you want to get a lot of inputs, like what's the area of the house, how big is the yard, and data like that, and the output is the price. Yeah. So what did we use for input? So we basically, in Sweden, there's Lantmäteriet that has a large database. So the National Survey Agency.
Yeah, with all the different lots.
Yes, exactly.
In all of Sweden.
So you could get some basic information about the house from there.
Yeah.
But then the magic happens when you have the coordinate of the house, because then you can tie it to geographic neighborhood. So we had like distance to Systembolaget, how many Systembolaget.
That's an important data point to have.
that was the driving.
So loads of points of interest, and you know what the sort of most important, by far the most important and predictive.
Okay, no, I don't. Okay,
election data.
Election.
Oh,
yes.
Really? How people in that area
how people
voted?
in that voting district voted, yes.
Oh, that's kind of interesting.
As a good coefficient for determining.
Yes. And we learned there also, since we got also the demographic data from SCB and so on. It was we could see very interesting things. We saw, for instance, back then, I don't know if that probably doesn't correlate now, but Sverigedemokraterna in the south had the exact same demographic properties as Vänsterpartiet in the north.
Don't tell that to people. Okay.
With very high statistical and
Yes.
mathematical precision, you guys are the same.
And the worst, the strongest predictor of a neighborhood going to hell and prices going down was the amount of Kristdemokrater in the region.
This is what data-driven means.
Yes. But it was
fun.
funny because we got pretty free hands to put this into production, and when we did, so the result was super good. But then they started getting questions like, "What data are you using?" And then when the oh crap, we have to go and tell them that we use voting data. Then it was but of course it's aggregated. It's on a district level.
So even with today's GDPR problems, it still would be okay.
Yeah,
I guess,
so
in
it's
that point.
1,000
So-
people in one voting district.
Yeah, but it's interesting that how to determine the feature that really matters.
Yeah. Plus, I mean, there's obviously, and I usually go on about this, and we already did then, is that there is a massive risk with these kind of systems. I mean, it's super tempting that you get these fantastic results, but basically what you're doing is that you're reinforcing what has been rather than what you want the society to be.
That's an ethical topic right here.
Absolutely.
Cool. So you had a system; it could basically predict the value of a house in a better way than before, and then I guess a lot of banks were basically starting to make use of it as well. Right?
Yes. So as far as I know, it's still in production, and the banks use it. They tend to be slow at shifting things out.
Well, they got your system in, so that's a good thing.
But we were really terrible at business back then. So this was like we did it on a consulting basis. With that we get to keep all of the source code as well. But basically they were able then to run it for at least 10 years without paying us anything.
Oops.
It's a bit sad. Cool. Well, that was some work you did, and then it turned into this thing in 2015 and 16. What happened then?
So basically around 2000. If I back down to 2008, 2009, so GPUs were making an entrance. It was very clear, like, okay, wow, this is really cool. I can do these calculations very fast. So let's add GPU support. And we did, but the problem was that it was so early that the compute framework, CUDA for GPUs, was evolving like on a weekly basis, and we had no chance of maintaining it.
And for people that don't know, this is before TensorFlow even existed, so to speak,
Oh, yes,
at least publicly.
And then around sort of 2012, 13, 14, 15, sort of the AI, the market was taking off. Our software was getting outdated as deep learning was taking center stage. And we had the choice of basically, should we grow organically with our customers, or should we take an external investment? And it sort of came to its edge where we had a project together with SMHI, the meteorological agency. And basically the project was about improving wind power forecast.
Wind turbines.
Wind turbines, yes. Because the models that are out there are, tomorrow the weather will be like yesterday. That was a sort of
a good baseline to have.
So we started building a model for that and got some result, and then we realized the weather model that SMHI uses, that's a very, I mean that's a finite element method based simulation that's built on a few very simple mathematical equations that may not always hold up to reality. So we got a bunch of satellite data, and SMHI has a data set called Mesan that doesn't predict the weather, but shows what was the weather an hour ago. And you get everything, you get like a map with temperatures, wind directions, humidity, and things like that. So we built a system that to try to predict the weather 48 hours ahead, and it worked really well. And the big thing here wasn't the improvement in accuracy, it was like the improvement in cost. Because we could do in milliseconds what took many hours on a supercomputer. We could do it on a cheap computer.
Yeah, that's another one of the most cool projects I think that Peltarion has, about being able to do weather forecasting basically in a really efficient and fast and cheap way as well. Yeah, really cool stuff. So predicting value of houses and doing weather forecasting and what can you not, on dancing, and yeah, a lot of cool stuff.
And what was the sort of shift to what Peltarion is today? Or like, what's the
so basically at that point, I never finished
Exactly.
the story. Yeah, so it was basically we had this weather model that was like, okay, this seems great. How do you commercialize it? And then we met with EQT Ventures, who became our first investor. And met with a team there that were basically they weren't really their interest in the meeting was that they had a project of their own called Motherbrain that tried to predict who they should invest in. But then they looked at what we've done and then they said, you idiots, you shouldn't be like looking how to commercialize a weather model. It's your platform. You should. That's the big thing. You should continue doing that and don't get sidetracked on these sort of vertical implementations. But you should do it properly financed and with modern technology. And we were super happy that it was somebody who really understood. So that was the.
So in a way, they were part of shaping the end idea where we are going now, like in these conversations.
They were the one. They reinforced that the sort of core idea that we had there, that there was something.
Actually,
in it
even first idea.
Yeah.
Even
because what the current platform is a modern version of Synapse. It's cloud based. You have GPUs. It's there's come new things like transfer learning and things like that. But at the core, a one-stop stop where you can import your data, look at it, build your models, train them, deploy them. Sort of that thing is the same, but a couple of order of magnitude more complicated because it's cloud-based now. So it's not just somebody running a desktop software on your own computer, but it's many users simultaneously distributed in the cloud. So.
Cool. So you got some funding from EQT, and then you started to grow from being a 2-people founder-only kind of company to how many are we today? You would say?
A bit, slightly under 100.
Yeah. And we got there was some additional funding, right, as well after EQT.
Yes. So after EQT, the Wallenbergs came in.
Yeah.
And this was a part of a larger thing where we. Basically, what we're seeing then, which was a couple of years ago, but still seeing today, is that the US and China are really leading the AI race.
Right.
And that we have to do something to be competitive. And this is not a zero-sum game. I'm not saying that because we are losing out because China is good. We're not. But we have to have something to contribute as well, since everything is based on trade.
But maybe we should sort of move into take this as a starting point for a theme, or if I can set it up a little bit. So I would like to explore how you see the AI landscape today. Like, what is the AI landscape? And now I'm highlighting we have industry. You are part of the industry to some degree. We have the public sector, private sector, we have regulations and people, and then we have on a macro level different superpowers. We have countries, but even, is it countries or is it super mega companies in these countries? So maybe how would you see the AI landscape? If that's my broad question, and you can sort of zoom in, and you can start on the tangent. You were starting on one tangent. What's the AI landscape about?
Yeah, but I can zoom out a bit and sort of focus in on that later. But if you look at the sort of breakthroughs, why we are here today, why we have this show, is because of a number of academic breakthroughs that happened around 2012 that made these type of algorithms be able to perform things that were impossible before. And this came from academia. And this was relatively quickly followed with sort of the big tech companies, in particular Google was very
early to understand the value, they understand the potential, and just running with it.
Exactly. So they started buying up departments.
They were buying up university departments.
Yes, essentially.
And you say in 2012, you basically mean the AlexNet and computer vision and image classification, and that type of things. Yes.
So that was and basically in some ways it's in one way it was overstated, in one way it was understated. It was stated in the way that in practice, if you look at what happened in 2012, it was images, basically anything that could be expressed as an image.
So computer vision is
Yes.
Computer vision is really what we're talking about.
Exactly. Here. Now there are millions and millions of use cases for that. So I don't want to say that it's not important, but it's sort of at that point where people started to attach the ideas of general artificial intelligence and sort of all of that talk became popular. So they ended up at Google, most of the academia, or the great people at academia. And lots of their PhD students. And those companies are American. And there are some universities that manage to recover, and there are some universities that are really great today at AI. But for the most part, and including Sweden, this was a relatively hard hit. We had very talented people working in academia in Sweden who left for Silicon Valley. For better pay, for opportunity to work with the best methods, best computers, and so on.
So brain drain from countries and academia into tech giants.
So in 2012, a true brain drain.
Yeah, I think it was probably around 2014, 15 that started. So it took a while to get started, and then China sort of came in and filled a void in the academic space. I would say in. Around 16, 17, sort of they started to become dominant with massive funding of their universities. And it became scary sometimes when you saw like who's the best at this type of algorithms, and you would say the People Liberations Army Secret Security Division 5 in Beijing. Okay. And when it comes to industry, it looks very, very different in different fields. And we also have the confusing fact that as AI was gaining popularity, AI was becoming a much more inclusive term. So hyped term.
Slapped on everything that moves.
Yes, or at least there was less and less of differentiation between that this was actually deep learning that was driving this, to generalizing to any type of AI, and then in that was included traditional machine learning, and then it was basic statistics, and then it was if I write an if.
So now a small sidetrack, but as part of the context of the AI landscape, what is your definition then of AI? The 1 second, 2 second, 5 second, is it deep learning we're talking about as the true?
So there's a difference between the sort of what I think is the definition of it and the way I use it.
Yeah.
So my definition of it would be a software that performs some action that requires intelligence.
Yeah.
That would be sort of or software technology that. My own definition, when I use AI, I am a bit chauvinistic, so I mean deep learning. If I'm talking about other machine learning, I typically call it traditional machine learning. But
because I think it's very interesting now, and here we sit with super experts, and I think it's a very fair, valid question to have, also to calibrate the conversation. And I think it's fair that, within this context here, now we talk about the AI landscape, we're talking about the brain drain, it has a lot to do with the deep learning context.
Yes. So, and now when it comes to industry, so the AI, call it the AI revolution or the deep learning revolution, it coincides with the digital transformation of industry. And those two are very often intermingled. And there is a natural relationship. But with the sort of co-option of the AI thing, I think there's one thing that becomes a bit opaque, and that is that there are actually very few companies that have deep learning systems in production. You'll find the big tech giants and then some sort of the super unicorns like Spotify or Uber or things like that. So sort of the big one.
And I think this is a profound truth to talk about quite a bit, because this opaqueness or this misrepresentation is also in some ways hindering us for looking cleanly at what deep learning is all about and how we can use that as a new coding paradigm. As you like to say, you don't need all the fancy big data stuff. You only need deep learning on the right data. I mean, like, so it's, and we have talked about this before. It's like, we get misled by the analytical ladder, right? You need to do this before you do that. No, you don't. No. So let's explore this even more now, because I think this is really interesting for everybody to, how you see this point and how it really...
I think that's an important question, but just to close the discussion on the AI landscape before.
Please. Sorry.
So we have the big tech giants in US and China, and what would you say the situation is in Europe and Sweden if you try to compare the AI readiness level, so to speak?
If you look at the past 2 or 3 years, companies in the US, and I'm specifically talking about more of the sort of California and New York region. I'm not sure about
the average company.
The average company, but the sort of knowledge and the adoption of technology is far higher than in Europe. So we are lagging behind, and it's not good.
So the big tech companies are really accelerating fast.
They are, and there is an openness to using this technology that we haven't seen in Europe, be it either because of the organization styles or...
So let's park that question also, because now we have landscape, and now we have 2 major themes to come up around the corner here. Why we have problems,
What's the problem, the struggle for companies to get started with deep? And that's another, very important topic.
But let's take I think it's any other angles on this landscape, or is that sort of, I think that's a good macro summary right here.
So so I would say right now where we are, you have a predominant US domination in the technology, and especially when it comes to algorithms and practical sort of applications of them, or that, and then you have a lot of strong research coming from China. So these are the sort of 2 big theoretical bases. The space that hasn't been occupied yet, and that we believe that Europe has a great chance, is in the tooling space. Because ultimately, no matter how cool these algorithms are, unless they really get into the hands of people, and more people beyond just the tech giants, they're not going to be that useful. So I think we do have an opportunity. We haven't, it's not a done deal that Europe will be a zero in AI and everything will be dominated by the US and China. Just look at the steam engine, for instance, British invention. What really changed the world there was not the invention, it was a necessary condition, but it wasn't a sufficient one. And what really sort of made steam engine ubiquitous was the machine tooling for building a steam engine. When it became very cheap to build a steam engine, then it exploded. And the Americans were really good at this, even though it was a sort of British invention, and England dominated the sort of steam race.
So when the actual tooling around building steam engines became easy to use, I guess, or
cheaper, widely available, when there was machine tooling, so that it wasn't, each steam engine wasn't meticulously handcrafted by a few experts.
So then it really revolutionized the world, and the steam engine, started the industrial revolution in different ways,
exactly.
I guess.
Yeah, it was all about automating physical power. And I think it's an apt analogy to AI, where we are looking to automate things that require intelligence. So it's there is a nice analogy there. And also now that we are in a situation where most AI systems are handcrafted by experts.
But let's, just before we wrap up the sort of landscape topic, one angle that I think is also quite interesting to explore, where you think it is it's also a little bit about where the main trends go, like what path are we on now? So clearly we're on a path of, that we've been on for some while, to use smarter ways of processors with GPUs, right? And now we see next steps, GPU processing even going all the way into visualization tools. So this is one key trend. And then we have the whole GPT-3, the general, those kind of, transformers trend. Then, of course, there must be a fundamental trend that I think has, if I take the more generalist view on this, not only deep learning, but I think it goes into anywhere, is the fundamental trend of simplification. So to quote from a Gartner conference a couple of years ago, when do we go from scarcity to abundance? Like a real tipping point. I think this is a major trend. So we have an abundance of data, but we have scarcity of value into tree production value. And what is sort of driving from scarcity to abundance? Well, it's when it becomes simple enough for everyone to use it. And the great example is internet, of course. So it's been around for 20, 30 years, but we all recognize it from the mid-90s. And what made it abundant was the web browser, yeah? So I think this scarcity, I think it's a major trend to go after. Would you agree with those kind of core trends, or am I some more?
Yeah, absolutely.
And just to continue, or perhaps move into the other interesting discussion, which is, why are people outside of the tech world or the tech giants, struggling to get started with AI? I heard this funny term just yesterday, I believe. They basically call it the AI graveyard, or the prototype graveyard.
Yeah, the pocket graveyard.
Yeah, so many companies are trying it out, but usually stops at the prototype stage and really, or very rarely put it in production and get value from a company. But the tech giants do. So what would be your explanation for that?
So if we look at it from the, say, enterprise perspective, sort of the larger companies, so first you encounter the problem is that you typically have a high-flying AI vision and data transformation, which is enthusiastic, ambitious, and super fluffy. And then you have a layer of middle management that don't understand anything what's going on. And then you have a small team of experts who are, we're gonna build this cool stuff ourselves. Everything from scratch. So there's first this disconnect in the organization between the initiatives. And the only places where I've seen it work is where there's a really clear agenda that goes understanding both top down and bottom up.
So I love it. So strategic can be translated to tactical, can be translated into operations, and vice versa.
Exactly. So that's one thing. Another thing is it's pretty mundane, but it's basically it's complicated to put a system in production today, a deep learning system. It requires many moving parts. It uses exotic hardware like GPUs that you have to manage, and it's built on experimental software that keeps changing. So getting out a prototype is relatively simple. You do a one-off data acquisition thing. So, look, I have a CSV file with the problem, and you build this a quick neural net with some tool, and look, the results are amazing. The cost of doing that is nothing compared to the cost of actually putting it into production, making sure that you have data pipelines, that you sort of can regularly feed it with data, making sure that you have, when the system is in production, that it's stable, that you have monitoring. There's a whole world around it that's far more complex, and where you're sort of building it on quicksand because the tooling is so experimental.
So I guess this is another analogy back to the steam engine, that we can make a steam engine work if you have some passionate people to have like a prototype of the steam engine, but to really make it valuable, you need to build 1,000 of them, or
exactly
have they work in a great way, right?
And then I think one of the sort of I would say the sort of main experience from our interactions with customers, what is always the most difficult bit is that when we come in as AI experts, we don't understand their business and what their priorities are. Right. And at the same time, they don't understand what AI is, what it can do, and what it can't do. And making that bridge, that's the sort of a key bit that's always complicated. And I think long term, the solution is better education in AI, that everybody should understand really before what it can and can't do, and what you can expect.
But so let's take those bullets down, because I concur with all of them, and I've had several of my key presentations has been in several of those areas. So the first one was, we talked about making it connect the whole way, not too fluffy, but from strategic, you need to have one agenda sort of thing. There is a fundamental this is complicated stuff, so you need to have respect for it in this way. Difference between pilot versus really making it work. And then the last point here I think is equally important. The future is, I use the word intersectional innovation. So we are living in a new core, which is a domain expertise married up or infused with data and AI expertise. And I think this is profound because those things also means how do we organize this? How do we work together? How is our fundamental educational system looking like in order to support us living in the new core in the middle of the Venn diagram? So I think it's really cool. It's profound, yeah.
I'll add one a bit more mundane thing, but where I see companies fail so often, and that's being so caught up in the sort of idea of AI that they're not thinking through the logistics. Like, for instance, one company that we work with that had the idea of basically, we can use drones for inspecting something or other. And when we broke it down, it was like, the AI bit, it's just image recognition. We can do. But you're actually suggesting you build a fleet of drones. How are you going to transport it? How are you going to manage the logistics around it? Yes, it's a super cool use case, but there is no chance this is going to go beyond some guy just with one drone doing a proof of concept and say, oh, great, we can do this inspection by drone. Yeah, but you're not going to put it in production.
Yeah. To have a more holistic understanding, I guess, of all the steps necessary for getting everything.
And before we leave this subject, are there any simple? What's the number 1 or 2, 3 things? If you flip this, get started. What is the number 2, 3, 4 things? You just get this stuff right, please.
Commit to deploy.
Commit to deploy. Yes. I like this.
So when you start an AI project, write it down in blood that this is going into production. And many of the problems will solve themselves. So don't accept that this will be a proof of concept. We're just seeing if this works or not, and so on. So really be committed to actually getting into production.
That's a sound out in commit to deploy. It should be written on some T-shirt, I think, somewhere.
Actually, it's written on this cap, airplane. Oh. We have too many pilots, so we need to give them an airplane to make them fly. So it's actually the whole idea behind that word airplane is actually commit to deploy.
Cool.
Yeah. Awesome. And just to connect to that a bit, a lot of companies are trying to get started with using data in different ways and become data driven and have an understanding of all the KPIs that they have, etc. And we spoke a bit about this an analytical ladder that you can have in different steps in moving up in that ladder and perhaps at some point reach the magical term of AI.
Now we are ready for AI. Not until now. We need to do this and this and this and this first.
Oh, it's one of my favorite topics.
Or worst topics.
Worst topics, yeah.
Okay, so what's your thinking about analytics versus AI?
Yeah, so people tend to confuse them. And the difference is with analytics, the goal is to get some information that you can act upon in an intelligent way.
Yeah.
And typically the process, the way it's done is that you try to centralize as much as the data that you can get hold of from your company, aggregate it, have a data science department that looks at the data scientists that analyze it, and then they come up with a dashboard or with recommendations and things like that. This is super important. Companies should do it. So I'm not saying that analytics is not something one should do.
It's one discipline.
It's one discipline. It's a super important discipline. AI is something different. AI can be applied to analytics.
You can use machine learning or deep learning techniques when you do advanced analytics.
Yes. But AI is I think you in our conversation earlier, you expressed it pretty good. It's an engineering discipline.
Yes.
It provides a solution to something. It automates something. So what you get out is some sort of optimization or a business value or a cost reduction or things like that. And the great thing is that it does not have to be centralized. You don't have to wait to have all of your data lakes in place and all your data. Problems can be solved locally, and typically they are best solved by domain experts. again, this difficulty of bridging the business understanding and AI. Say that you have say that you're an antenna designer at Ericsson. You worked with antennas for 40 years. And now here comes this newly graduated data scientist from the Central Data Science Department and says, you're building antennas. Would you like to add some AI to that? That's not going to work.
No.
The sort of domain knowledge that sits in that engineer is vastly bigger than what the data scientist can help with. And imagine also the poor data scientist, who's one day he's talking to that antenna guys, next day he's talking to the guys doing the billing.
And then marketing.
And the marketing, yeah. So it puts impossible demands on the data scientists. And yeah,
I guess it's the catch-22 problem of either you learn AI experts to know all the domains, or you learn domain experts to learn all of AI.
Yeah.
And both of those, I guess, is very difficult to solve.
I think ultimately, for me, this is easy to solve as soon as you recognize that this is a true team play. And it's not a team play where you can have two different organizations where you ping pong in between each other. You need to have a team play in a daily life, over time, iterating, sweating, having blood on their shirt together. And then so it goes back to the whole organization. Do we put it centrally? Do we put it together with a domain expert? Organizational wise, there are many options, but work wise, blood, sweat, and tears together over time. And I think what I try to say here is that the domain expertise have their lingo, they have their understanding, they have their deep understanding, and here we have someone with mathematical or coding and all that kind of stuff. And these guys talk Python, these guys talk Latin. If I'm in a doctor AI for doctors, I used to joke like that. And to me, it's that simple. How do we find our common lingo? How do I, as a domain expert, try fully understand the prerequisites for neural networks? What is the parameters when I can do a certain type of
So how do we solve this, Luka? Do we train the domain experts, or do we train the AI experts, or do we do neither, or do we do something else?
So I think a combination is needed. I think that a lot of things can be solved by training the domain experts.
Yes.
And then you need a layer of experts that can help out when things get difficult or things need validation and so on from the AI side. But you can get quite a lot by training the domain experts. That's my...
And I guess the tooling can help a bit as well.
Absolutely. I mean, you can bake in a lot of the expertise in the tooling, and you can eliminate. But it's also, I mean, the state of AI today. I mean, you had Carl Tomé last week. What was he talking about? Kubernetes. Why was he talking about Kubernetes, which has absolutely nothing to do with machine learning and AI? Because it's something that he has to manage in order to do AI, and he shouldn't have, because it's not core to the problem he's trying to solve. And this wheel is being reinvented and requiring expertise that is it's even beyond just the data science competence.
No, the stack as you to manage the full life cycle from idea to deployment and production takes you on a quite interesting journey.
Yeah,
tech-wise.
Exactly.
So what's your vision then? What do you think in 5-10 years? What would you say that the best type of organization and company would be that can scale up use of data and AI in some way?
So that's a good question. I can give many examples that haven't worked, but I think some combination of where you have it also very much depends on the company. If we assume an engineer, technical heavy company, to simplify things, then I think the sort of approach that works is when you have a centralized center of excellence and data science department, and then you train all the engineers in using and building AML, so that the engineers in the company in the different departments are sufficiently self-sufficient that they can handle a lot of stuff. And then when they need help, when they need more education and so on, they have this center of excellence that they can turn to and get support from.
And I've heard you use the term decentralized AI, and we're not speaking about federated learning right now or swarm learning or anything. What do you mean with the concept of decentralized AI?
Basically, that individual business units or even teams can solve a problem they have without having to involve the entire company and making it into a very heavyweight process. So we had an example of a company that produces industrial goods, and one of the sort of challenges was that they were in a big, or are still in a very big digitalization process, and the question was like, what can we do with AI? And one of the things that we came up with was that they have a production line where they inspect things for quality, and in that case, you can rig up cameras there. You can it can be solved by the local engineering team without to get the data to connect it, and with the right tooling and so on, it can be solved without making it into a massive process, but rather making it rather quick. The downside of that is, of course, that if you keep doing that for 10 years with everybody running their own AI solutions and not doing anything about the data, is that you'll end up with a mess eventually. So there needs to be a feedback loop to some sort of centralized bit.
Cool. So I think this is one of the key challenges of also how to go about this, how to get started without blowing up in a huge project, but at the same time have a learning organization or a feedback loop. So this is I think one of the key topics, how to crack that nut. I think there is another key nut to crack, and that is the fundamental orchestration topic. I mean, like we have different stakeholders in terms of who owns the P&L and what's the business perspective. Then we have an engineering perspective. Then we have a data perspective. So also how we work, and we are not used to these cross-functional setups that is, in my opinion, required. So even if you go and find this problem now and you can solve it locally, it's still fairly, there many different parts or competencies or different functions within that business unit that need to come together to make that actually a good deployment in production that is used on everyday basis. Because it's not only about rigging that hole and getting that data to work. Well, how are you going to get it back into the normal daily workflow, and who is the boss of that, and all that?
Yeah, absolutely. I think there is a strong case for the future, especially if you talk about product companies and so on, that have some sort of agile workflow and cross-functional teams, to add data scientist or a machine learning engineer as a part of that team.
I think that's a good one.
But the problem today with that is that there is such a massive gap. And data scientists, especially with the complexity of tools, it's not like you can have one data scientist to build, unless it's Carl Tomé, who's amazing, who can build an entire production system and platform in place locally. And that's also why data scientists typically work in teams today and as a coherent unit. So I think you run into a lot of trouble there with just adding a data scientist and having just this sort of technology with the technological complexity that is there today.
And a little bit, that's part of the whole pilot graveyard, that we have done exactly that. And they were able to figure something out in their notebook based on their CSV file. Yes. But the rest of that story is not covered.
Exactly.
Yeah. It comes back. It comes back to this.
Yeah.
But it's
difficult things.
But are there any? So did we boil down this to any guiding? What was the fundamental? We understand the problem deeper and deeper and deeper. But do we have good, simple guiding principles on this, or is that basically very contextual for each company?
So it is very so each time when I think that's like now we've cracked the formula for enterprise, then you sort of meet another company. For instance, the model I presented there, like for an engineer heavy company, it completely falls apart if you have a company that consists of people who are not engineers, but non-technical. Large company has tons of non-technical people. Departments, and then you're suddenly okay. Either we inject technical people there, but you can't really, because in this particular case, this was a very decentralized organization where each unit has a lot to say and have their own business goals and so on. So it's sort of, in those cases, it has to be start as a central initiative, and then over time that you try to work yourself to.
So it's about context, it's about size, it's about maturity, it's about the opportunity of data literacy or engineering literacy.
Exactly.
That basically have it's a smorgasbord of things you can do, but it's a little bit like we need to pick a starting point that is relevant for these.
And then also one of the other things is that AI can typically strike at the center of a company, of a sort of core of the business. And there is a decision to be made there, which is like, do we do this ourselves, or do we hire a consultancy firm or use a vertical AI company's product and so on. And that very much depends on sort of what the goal of the company is. If it's just a service company, then it makes sense to use off-the-shelf things as simple as possible, replaceable products. Just try to hobble something together as cheaply as possible, and do it like that. Well, if you have a goal of building value in the company, so if you want to go more to the product as a service or something like that, then you have to start making sure that you actually own the IP to the things that you do, because otherwise the software that you're using that's generic will be used by all of your competitors, and you won't have any IP.
So this is a quite interesting topic. We had a Mikael Klingvall here. He's a data scientist at Vattenfall. I used to work at Vattenfall before, and I think this is one of those fundamental topics. What is our core business in the future? And we always talked about this in Vattenfall, that actually the algorithm of the wind farm optimization is our core IP. So when we had discussions with Siemens, we should we outsource? They wanted us to do stuff, or we manage it for you, buy our software, and we were flipping it around. No, we don't want to buy a black box out of you. We might want to buy algorithms of you, but we want to run that in our data center because we have other data. And by the way, we are trying to do return on capital employed, maximize best maintenance. So I'm not only looking at the turbine vibration, I'm also trying to schedule, based on how I can sell and price my energy, which you can't do. So I think this is core what you're saying now, because it also means a little bit to take a step back now we like our Elon Musk first principle. So if I take a company like Vattenfall, is AI even part of their first principle business? I think it is. If they are ultimately here to produce energy to sufficiently optimized, it's a core cost.
You have to find the correct level of abstraction. If you say should Vattenfall build a cloud of its own?
No,
called Ånga. And
Steam cloud.
Steam cloud. No, but should it
That's true. So where do they draw the line? What is core? Exactly. So maybe the tooling is not core, but the algorithm is core.
Exactly.
Is core.
But
I agree with that. I fully agree with that.
What's the sort of the curse of the vertical AI company? And we've seen this a bunch of time. For example, we work with an insurance company where they wanted to do some car damage assessment, I think it was. Anders, perhaps you know better. But basically, our first initiative was to push them towards. There is a company that does this, Tractable, that does it really well. It's why are you talking to us? Why do you want to reinvent the wheel? Go with Tractable. They are really great at this stuff. But they were no, this is our core business. We want even if what you build will be inferior to what they do, it will be ours. So it's it will be our crap. So it won't be somebody else's.
Oh my god!
So it's
interesting.
But if you want to build, I mean, there is a risk if you just pick and choose different AI. So I'll take this from Google, this from Microsoft, and so on, and just connect everything. Is that ultimately you haven't built any value yourself? You're just using services that are required to run your business, but you don't actually create any added value in the business.
It's a patchwork of different systems or something.
That as well, yeah.
Cool. Before we move too much into that, we have a lot of topics we'd like to cover, and speaking about the Corona situation of today and how to reboot companies and whatnot. But before we move into that, and perhaps AI for good, that I know you are very passionate about as well. I don't think we closed really the lid on what Peltarion really is and what the vision is nowadays. How would you describe the vision of Peltarion?
So it's on your T-shirt.
Sorry. Oops. Okay. So try to elaborate a bit more, perhaps.
So the vision, which is sort of where we see the world, where we want to see the world to end up, is AI being ubiquitous and doing good for humanity. Yeah. Basically. And why do we want that? Well, because it's much better than AI doing bad for humanity. I think we decided.
Sounds like a good idea.
But there is a massive potential in this technology, and it will be transformative, and it will be great if it can be used to make the world a better place. The way we're doing it is basically, and that's more of our mission, is to make AI accessible and affordable for all. And
not just for the tech giants, but
exactly, not only for the tech giants. I should qualify that a bit, sort of where we are at this level, because I remember there was an interview in some British newspaper, and they used the analogy of WordPress for AI. Like, before WordPress you had to write things in HTML, and it was just a few web developers who could do it, but then WordPress came and anybody could do web pages. And I said, exactly like that. And then we got these pissed off emails like, I know how to use WordPress, but I tried to use your platform and I couldn't. So it's directed at still today at people with a level of technical skill, sort of engineers, developers, analysts.
So who's the target user as Peltarion platform is today?
So the technical non-data scientists. We usually
software engineer.
We usually say engineers and developers, but it's a broader. So this could be we've had one of the most active users of our platform is a medical company with medical people using it. But it's always some degree of technical knowledge behind it. But it doesn't have to be AI knowledge or data science knowledge. And that's
awesome. And going to Corona then, this is a weird year for I think everyone, and a lot of companies are struggling to just survive at these times. And we know that the Swedish government, European, American, Chinese, and everyone are going to put a lot of investment now in trying to reboot companies, trying to, for one, make them survive, but perhaps also transform a bit and become more sustainable in some way. What would you suggest or advise people to, for one, that perhaps have a company and are really struggling right now, but they want to, continue to be sustainable for a long time? How would you, advise them from a data and AI point of view to continue?
I think that's a hard one. I think one of the special thing about the Corona crisis and the economic impact is that the companies that we are seeing are struggling are in certain sectors. And it's not through any fault of their own. So it's not that they were doing something bad and that the market is killing them, but it's the virus, basically. So it's an external factor. So this is not conditioned by these restaurants and airlines and so on doing things badly. Although they are, but that's a separate... that's not the reason for this. I mean, what we're seeing is an acceleration towards the digital, or at least claims, I should say. So there's a lot of talk of how fast digitalization is going now post-corona. But my fear is that people think like, yeah, we're using Zoom now, so we are super digital.
Yeah. It wasn't the Swedish educational minister that said basically that 3 years or 3 months of corona has improved digitalization more than the last 5 years or something, but it's basically using Zoom. That's the thing. Right?
I have a sneaking suspicion that's sort of what people mean. But at the same time, what we're seeing from companies that we're working is that everybody has expressed that digitalization is now priority number one, and we're doing it now. We can't put it off. So it has definitely had
So it has really raised the bar of digitalization, number one. And I fully agree. Well, what we actually done or what we were forced to do had more to do with digitalization around collaboration. That whole space exploded, right? But do we think that they have now actually, that's just the starting point now, and we realize, I mean, like, we don't have resilience in our processes. Our processes doesn't really work so well when I need to work at home. This manual paper stuff, So I think they see also that, well, we now use Survive by collaboration tools, but in reality, we also understood how vulnerable we are. So maybe that's also a point that from one part of maturity, I guess, is the urgency to act, commit to deploy. The commit to deploy went higher.
Another thing I think that was highlighted and that is highly embarrassing is how little AI has done anything in the corona crisis.
What do you mean? Can you
elaborate on that one? That's a good one.
So it's basically the data isn't there. Talking from the Swedish perspective, there isn't the data that's required to use the AI or even basic analytics to predict things like how it spreads, where it spreads. Does it spread in schools or not? Simple things like that. And it's a combination of very non-digitalized things and GDPR or unclarity about GDPR. For instance, in the Stockholm region, there were tons of companies, us included, who offered the region the services pro bono, and just like, give us data and we'll do something. And they weren't able to because they really couldn't navigate in GDPR. They thought like, oh, this is we don't know how to anonymize this data. We don't know if even if we anonymize, if we can give it out, and so on. And after sort of lots of talks back and forward, their decision was, we're going to hire a data scientist ourselves. That's like, seriously, that's not going to lead to anything. I'm looking at the world in general. I mean, it's not like we've seen a vaccine being created by AI, and
not yet, at least. Right?
Not yet. So this data situation is relatively poor worldwide.
And let me see if I understand it correctly, because we are all a bit marveled, I guess, over how bad the prediction, even human prediction, not necessarily AI predictions all the time, but even human predictions in if it's going to be a second wave or not, or where it's going to spread, and who is going to be hit the most, and what the economical impact will be, and the medical impact and whatnot. Is that what you're referring to a bit? Saying basically that the predictions in general, both human and AI made, are really, really poor, and the confidence is close to zero?
I don't know if anybody has asked GPT-3.
That could have worked.
Just ask GPT-3 when will Corona end, and it will say.
Well, we will actually have Lars Albertsson as a guest here. I'm not sure if you know Lalle. It's a friend. But he basically at the Data Innovation Summit last year, he made a very controversial speech. He basically took up a lot of the big COVID models and tore it to pieces in terms of quality and how super inaccurate it was and how piss poor data engineering there was before. So these cannot be trusted, this is shit here. So there is quite a lot of truth here also, that we have sort of seen an explosion of visualizations which is also dangerous. There's been, and now we're talking Hopkins data, right? We're talking real data, right? That the actual craftsmanship behind it has sent governments in the wrong path in UK, as an example. So there's a lot of interesting stuff here to be explored.
Let me ask a counter question. What is worse, these sort of misleading or inaccurate large-scale models versus Folkhälsomyndigheterna who uses Excel to do their predictions?
I guess that would be awesome if we could answer that.
I don't know. I can't answer that. Yeah. I don't know what's worse.
But I think it's been like in theory we have like everything. We have these amazing algorithms. We have the method of collecting data, and this should have been like the great moment of AI. And not really, not yet anyway. Let's see how long this continues.
And what would you say that the main reasons are potentially? Is it regulation that is a big part of it? Is it lack of knowledge in how to use data and AI? Is it tooling? What would you think? How could AI have helped more, so to speak, with the corona situation?
I would say one of the things, one of the scourges of, and this is not just for government, but it's also for larger businesses and so on, is the sort of overstatement of their digitalization readiness, where they do have a digitalization or AI initiative on the sort of fluffy level, and then on the specific level they do a proof of concept, a test, and then they go, oh, we have AI. Look, we're really on track on being super digitals. We have drones. How more digital can you get than drones?
It becomes a huge tick box exercise. Whereas my old CIO in Vattenfall, he always talked about digital sugarcoating, and we always talked about you guys. I was in the business. You like to eat the sugar, yeah, but you never take the cereal. You don't chew it in the real stuff. And I think, isn't that a key factor in itself now? The industry is hyping up what things can do and what things are. Kejsarens nya kläder. I don't know, the emperor's new clothes. The emperor's new clothes. And by the way, we do the same in the industry to show that we are on par with where we should be. And it's just a huge tick box exercise. But who is really investing to commit to do the hard yards, which is really, it's some hardcore dirty work to get AI to work. Cleaning up your data, all this, right?
So it's a lack of people actually using and I guess operationalizing AI properly today. It's very few companies that do that. But if we do think about like Sweden and perhaps at least enterprises or perhaps public sector, can you think of someone that is starting to at least have some kind of maturity in terms of using data and AI? Or
I mean, absolutely. I mean, there are individual examples, even in government. I think it's Region Västra Götaland is very Halland also. I think are very good compared to others. So it depends on sort of how they solve it locally. But in general, I would say that there is I mean, wouldn't you expect that now when we have how many, over 1 million, 2 million, 5 million, how many are infected worldwide, that we shouldn't have at least some tens of thousands full genomics and of the people, the complete antibody profiles, protein charting maps and so on, so that we can actually put some of the heavyweight algorithms on work and try to see which people are at risk, what brings immunity and so on. There's no guarantee that this will be an amazing result, but let's at least start with that, and that doesn't really exist.
So would you say basically that the maturity level now in enterprise or in Sweden in general is low for at least AI? But do you I guess you agree with that at least?
Depends on what you compare it to. I mean,
yeah, good point. Okay. So Sweden versus Europe then. Would you say Sweden is better than the average European country in terms of AI readiness?
That's a very good question.
I think it's an impossible question, and let me answer it from a
Thank you.
no, let me answer it from a very concrete company perspective, where when you work for a long time and you explore the inner depth of a lot of different departments, if I can't really put a scale, I can't. Of course, I can do a mean and average of a company, but Vattenfall, but they're more like a bell-shaped curve, right? It's like it's a microcosmos of society, and it goes also with who I'm working with a lot now. Scania is doing some super amazing stuff. I think the difference is to how do you do it pervasive? How do you do it enterprise, right? So how do I now? What's the scale we are talking about? Is it the best of the best? Is that your scale that we have that we're doing really well in a project setting, in production, fully in production, but in a project setting? Or have we figured out the pervasive approach, right? Or the orchestration approach that sort of, that the whole company as an organism is here? And that's what I'm trying to say, that very, very hard to pinpoint where the organism Scania is or where the organism Vattenfall is on this journey.
Well, there are some easy to explain companies. I mean, we know the tech giants, of course, heavy in the lead at least. So in some cases it's easy to identify. But then in others it's a more...
There are some. I mean, UK is fairly strong. If you look at, they have DeepMind is there, and you also have a good startup ecosystem.
But even I think Stockholm has a fairly strong startup ecosystem, right? I mean, we are scoring quite high on innovation. I mean, I'm not talking AI only now, but some of that is quite healthy here. So it's a lot of opportunity to draw on.
I personally think Sweden has actually a really good potential.
I think so too.
And we have a track record of a lot of unicorns in Sweden that
absolutely.
very few other companies have. So something is working for Sweden for sure. But it's not really that strong in AI yet. But I think it has the potential.
And I'm not so worried about the sort of digital native first companies and the sort of...
It's the proud analog companies who needs to, make a shift.
Yes,
and to be honest, I mean they are doing a lot.
Yeah, they're doing a lot, of course.
But a lot of other countries are doing things as well. I know you mentioned UK, of course. They had this kind of sector deal, I think, 2018, and putting billions of pounds into AI, and Germany is doing the same. And Finland is actually doing a lot as well, and they started even back in 2017, I believe. So some countries are really investing heavily, right?
Finland is in many ways a very impressive example where you sort of have a whole society support for AI, but they also have a tradition of it. I mean, they were also...
What do you mean? They stand behind when they want to do
in
something?
the sort of in the 90s and so many of the gurus like Kohonen came from Finland, so they have an academic tradition of dealing specifically with AI, and it seems to be continuing today. We've seen also that one of our partners, Silo AI, they were very early to hold talks for their government, for the parliament. The course that we have, the elements of AI that we helped bring to Sweden, it was done in Finland first, and so I've been super impressed with.
What's the ingredients where they have gone differently, or they have pushed more? What's the difference? What has Finland done differently to us in Sweden?
Perhaps that there has been a more central idea of that we're going to do this, and subsequently more understanding from the...
Commit to deploy.
Commit to deploy, exactly.
I'm going to print a T-shirt by that. Yeah, I'm just going to tell you that. I'm going to have that T-shirt. I love that expression.
Cool. I'd like to, speaking of Corona and speaking about medical use cases, I know you have a passion for using AI for good or for social good in different ways. And we had a number, or you had a number of projects in Peltarion as well for using AI for social good. Can you just mention a bit of your thinking there and perhaps something about those projects?
Basically it comes to this, that this is a really powerful technology that can be applied to almost anything. So, and it's very, very, very hyped, so everybody wants it. So why should we start off with something bad? Let's do something good instead. And this is, and that's one part of it. I think another part, and this is older, is, for instance, Måns and I, we haven't worked with the sort of defense industry, police and things like that. And idea is it's not that I'm a pacifist or that I'm against defense, but I hate the idea that I would contribute to, for instance, the design of more efficient landmines or something like that. It may be hypocritical, but it's the same way I'm not a vegetarian. I eat meat, but I like my meat to come in nice packages in the store. I don't want to kill the pig myself. Yeah. The same way here. I approve of defense. I have nothing, but I don't want to my work to go into that and the sort of subsequent thing. So I think it grew out of that into a more general thing. But there's one cool project that we're doing right now. I don't know if Björn has told you about it. So basically one of our investors, Euclidean, they are part of the Simons Foundation. So it's Jim Simons, who is a math genius and hedge fund billionaire, who started this institute after he retired to do research in the natural sciences, in math, and in autism. And one of the projects that we are doing now with them is that we're trying to see if there's a connection between autism and the genetics. So trying to use large-scale transformer models on raw genetic data to see if that can be mapped to the diagnosis. That's one of them.
And how does that go about? What's you're taking the genetic code, sort of all that data, and then mapping it and see how you can predict outcomes to the diagnosis.
So exactly. The core idea is comes from look, these models are super good at doing language, and creating a semantic understanding from something when they're trained word by word. So is it possible that you can sort of get it right from the genetic code to the diagnosis? It's still a hypothesis. We don't know. But if it works, then that will be, it wouldn't be just applicable to autism. It will be very widely.
So now here I'm learning here. Now we're talking transformers again, and the benefit with transformers is that it has attention. Yes?
And sequences, I guess. So to make, tech people also a bit happy here, I guess genomics is in some sense a large number of characters or a large sequence of genes. And basically it's, I guess, have some commonalities with text in some sense. And then the hope is that, the best thing we can do for text right now is, I guess, transformers. If we can transform that into genomics as well, then perhaps we can have a similar kind of success, right?
Yeah. So here comes the joke. So this must be a GPT-3 problem.
We have to stop making that joke.
You started this joke.
But it's, transformers for the non-tech. Yes, there are some technical aspects such as self-attention that makes it suitable for sequences and correlated stuff. But it comes down to you try to build this really, 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 really big thing, and you feed it a lot of data, and then you go, whoa, look what came out. So it's...
and by the way, it costs millions to run.
Yeah. But it's sort of what has happened in text. It's ridiculous.
I guess we have to go there.
You need to go.
You need to go
to BERT. Let's talk BERT.
No, but GPT-3 I was thinking.
Okay.
So I was going to jump XLMR. My favorite.
All right, go there. We need to talk a little bit about the cool stuff you've been doing with BERT as well, I think.
Cool, but we mentioned GPTR a number of times, and we mentioned it also in previous podcasts. But I think you have some thoughts about how cool or how good or how valuable is the research being done by OpenAI here for the massive model called GPT-3 with 175 billion parameters. Yeah. What's your thinking of the research that OpenAI is doing there?
So GPT-3 for those who haven't heard about it, it's a massive text model. It's about 1,000 times larger than anything built before. And it's been done by OpenAI. OpenAI is an American was an American.
It was a non-profit, but I think it's not anymore.
Yeah, so basically their goal is to reach artificial general intelligence and to be open and share everything that they have. They've changed it a bit. So what's interesting is that this model doesn't require fine-tuning on a specific data set, but it's so large that it contains so much knowledge that you can ask it everything from write a Shakespeare sonnet to create a user interface in code. So it's a massive leap sort of in the generality of what these systems can do. It's probably not very super useful for actual solving business problems today because it is very generic rather than specialized, but super impressive effort. What I think is interesting is that Open AI, who previously has been very open and released all the models as a standard in the industry, has decided to
withhold,
not be open.
Exactly.
And basically they are licensing the model exclusively to Microsoft, and then they will be selling it as a service API. And they are, of course, in their right to do so. They've developed it, so I have no philosophical objection against it, except they're not really that open, so maybe they should change the name.
Change their name, maybe.
Yes, and mission. But what makes me worried there is that it may set a precedent, and if Google follows, if Microsoft follows, if Facebook follows, and everybody starts keeping the models for themselves, then it will really, really be only limited to the tech giants. We're talking about the GPT-3. The estimate was like something like $10 million to train. And in that case, the sort of Europe, China, America thing becomes a bit more worrisome. And in that case, if we go from this open academic spirit that exists today, that when you find a great model, you share it. If that disappears, then since we don't have these tech giants yet, we'll have to invest in infrastructure
so the AI divide will increase significantly more. So
but the scary point is that as a European society, you never know where the pendulum going to swing, and you should feel the pressure even in the open context to contribute, because as long as you're not part of the game, which is truly, I think we're not part of the game, on the real big game we're talking about here, we are not really contributing here. So if you flip it from the other side, screw these guys, they are just riding what we are doing. So I think they're both from the open-ended side and also from the risk side of if the path you're describing is reality. Either way you flip this coin, we kind of need to step up. I think everybody in this room is quite clear on that.
So would you, if someone comes, and I get this question quite a lot, so I heard about this GPT-3 thing coming from a non-technical person, perhaps from a medical field, and they want to understand journal text or something, and they say, okay, I want to diagnose some kind of patient journal condition that they have. Can't we simply apply GPT-3 to that? What would you reply to that?
If you really want to kill your patients, go ahead.
Commit to kill.
Commit to kill. So I mean, GPT-3 is immensely impressive for its generality, for the variety of tasks it can do, but it doesn't do them really well. So anything that requires like accuracy or truth or anything, no. But there is another. So that was the sort of the pessimistic view, was like, oh my God, now they're starting to hoard the algorithms. They won't share. The open era of AI is over. Another perhaps more likely thing is that model is so hideously expensive to train and to run, is that for all practical reasons, the only ones who would be able to run it are the Googles and Microsofts and those. And that OpenAI thought like, nobody, the the people in general won't be able to use this, so it will just be us doing research and the tech giants not paying anything for using it.
Yeah, and still it's underperforming to like a specialized training model still. So it's much
Absolutely.
easier to run and easier to train. And so people have a so wrong view, I think, of GPT-3.
Plus, then comes the sort of thing of accessibility. And for all their power, the Googles and the OpenAIs and Microsoft, they have generally massive access to general data, generic data. They don't have specialized data, what will work in your industrial process or something like that. And so there the sort of data advantage disappears. And then we come to the cost thing. I mean, there are other examples of fabulous technological demonstrators that show off what can be done, like, say, the Apollo program that got us to the moon, but that are not financially viable today. And I think GPT-3 may exactly be that. It's a major milestone, but I'm
so eager to go to SpaceX here, but we shouldn't go.
No, but I think, but you're touching on one of my favorite sort of analogy. Is this all from scarcity to abundance? So the core topic here, if we truly want to do pervasive AI and all this, we need to crack the abundance problem. And then it's low cost. And then it's basically simple to use. All this, right? So, but it also implies, I mean, like now if we are strategizing for Europe's sake here, a couple of minutes maybe. So when we go, if going, okay, we need to have abundance and we need to have low cost. If I think now about tooling and how I can apply that and how I can be, good at what I do, you can talk about abundance and low cost, but for a niche. So I'm thinking also that this also implies a little bit like not everybody can have world dominance across all sectors, but you can take stuff and you can apply it and then you can feed it with the real data that is super relevant for some specific use cases, and you can really get good results for a manageable cost.
Absolutely.
So what is, so is that part of the formula here that, when we say tooling in Europe, we can be good in tooling?
I mean, obviously it will cost much less and be more accessible to build something that, say, categorizes a quality defect rather than building artificial general intelligence. So the sort of ambition level, the specificity is, it's far more manageable and more narrow goal. And I think in practical terms, that's where we are with AI today, where it is super useful, where you find these relatively narrow use cases. You can find them in many places in a company.
Yeah, so that's the point. You have. I start to look at this in a couple of companies now, and I can literally almost find it in every department, as long as I'm specific or clear about the problem.
So we could summarize that saying basically GPT-3 is trying to move towards general intelligence, but it's actually underperforming a lot for the narrow tasks, and simply the AI we have today works much better if we use it for narrow tasks and then combine it with humans in some way, right?
And
but if the time is flying away, so I'm trying to capture as many topics as we can.
Let's do it.
We skipped XLMR, my favorite.
Oh, okay. I added it to the list as well. But just continuing, or perhaps starting the next discussion about saying, okay, we know that fine-tuned models that are narrow works really well, especially when combined with humans. But then we have the big AGI question about general intelligence and perhaps the singularity, and perhaps what Elon Musk and Stephen Hawking and other Nick Bostrom and who not is really scared about. What are your thoughts about singularity? Is it a threat or a possibility? Do you think we will, if we pass singularity, have a better life or not?
So to connect it to the previous theme, I think just one interesting reflection is that, so this AGI discussion, it's been here for a long while. And with now the rise of AI in the past years, it's become increasingly popular. And I know that and I'm guessing, Anders, you as well, so sort of try to not to discuss that too much, because it was usually by people who have no idea what it is and so on. You just said, but that will be a worry for later. That's not now. What AI can do is this and this. But now with GPT-3, it's the first time that I've heard you, Anders, and heard myself actually talking about AGI. So I think it's going faster than I expected.
Yeah.
That's my thing. And as for the singularity, I mean, I share, I think, at the core Kurzweil's view. I think there will be a merging of technology and humans. So when we reach the singularity, we'll be part of it.
Back to Elon again.
Yeah, he's Neuralink, he's trying to do the same thing. Okay, so do you have any thoughts? So Kurzweil, for example, he has some prediction, I think it was 2029 or something, and it's kind of exponential thinking that he has.
Yeah.
Do you think that's reasonable, or what kind of time frame would you put it on?
I usually like to put it at a comfortable distance, like saying
2050.
2050. Yeah, that's a popular thing. I mean, these things are so difficult to.
But even to follow exponential curves is so hard, right?
Yeah, exactly.
So what is where are we now? And is it right here or is it still very flat?
Exactly.
What was it Bill Gates said something, predictions are hard, especially about the future.
Exactly.
Yeah.
But there is something about the exponentials. It's that humans don't process it very well. It's like with Bayesian stats that there's some circuit in the brain missing that
exactly. It's missing something.
Doesn't work.
Yeah. Okay, but just to summarize, are you positive or negative about 50 years ahead in 2050 plus or something that the AGI potentially will help society or destroy it?
I'll just read off your T-shirt. AI everywhere, advancing humankind. So positive, I would say.
Yeah. Great.
Good answer. Really good answer.
Cool. And we are a bit lacking on time, but you mentioned XLMR, and perhaps we should just also quickly speak about that. What's XLMR?
So XLMR, it's one of these language models, but the cool thing is that it's multilingual. And now what I really, really, really love about this is these text models, they understand text on a semantic level. So meaning not just the word, but the actual meaning of the word. Meaning that you can have two sentences that have completely different words but mean the same thing, it will understand it. Turns out this is true for any language. So there is a universal semantic language level across all languages. And I say, take that, postmodernists.
But so now we get into political incorrectness here. It's good. I like that.
But let's please dumb it down so I can follow you guys a little bit now. So we are talking about the language model XLMR. Mm-hmm. So how does that, maybe the most stupidest question, how does that relate to BERT or anything else like that?
So let me give you a practical use case, one that we did for a telecom company, actually Anders' idea and largely execution. So basically they have tons of RFPs, requests for proposals, meaning forms that they have to fill out and answer compliance questions, like are you certified for this, does it support this, and so on. And these answers can be long or short, and and they've been doing this manually. Now with the BERT-based model, what we were able to do was to automate this. Basically from when they get a question, then you map it to the answer to a similar question that was answered in a previous RFP. Works beautifully. Now that's English. Now, then came XLMR, which supports like basically any language, like 100 plus languages.
That's huge.
Mm.
Meaning that you can get the question in Japanese and map it to an answer in English. And then map it back if you have a similar answer in Japanese, answer back in Japanese without any translation actually being.
So you can use spit out RFQs all over the world, right?
Yeah, exactly. And that's
mind blowing.
Yeah, we're playing around. So we have now multilingual BERT in. development on the platform. We were just playing around yesterday. Wrote a Gmail plugin for search, where I can type like search in Swedish and get hits, get answers like in mails in English. So and it's no keyword matching, it's semantic matching. It knows what I want.
And is XLMR in any way connected to the BERT community and the BERT research, or is it different?
XLMR is Facebook, BERT is Google.
That's it.
And
Right.
GPT-3 is OpenAI.
And
Those are the
and
three.
Microsoft at least.
So, but it's a little bit like one guy is going here, and then the other guy is leapfrogging. Is it a little bit like this?
So Google,
Or
I think Google is largely trying
using
to
each
ignore
other's-
XLMR.
Yeah, I mean, they tried a multilingual BERT as well in
Yeah.
2018, but it was not nearly as successful as XLMR and the Facebook version of it was, and they trained on huge amount of data.
So,
et
do
cetera.
you
But,
guys
yeah,
know
it's
the
a
team behind it? Or like Facebook, right? But is it like the research, AI research department
Yeah,
in
yeah,
Facebook?
of course. Yeah.
Fair.
Fair.
What are they called? Fair?
Facebook
Don't confuse
AI
it with the
research.
more famous pair.
Fair.
Internal
Peltarion.
joke.
Internal joke.
I mean, we have a team Peltarion called PAIR. Peltarion AI Research.
Yeah, PAIR.
PAIR and FAIR, Facebook AI Research.
Yeah,
It's
but
kinda-
I kind of like it when I hear the Swedish tonation, and I think it's an A in the middle.
Awesome. I think we're moving towards the end here, and I'm thinking if we have missed some topic that we should cover as well. But I think we covered the most, right?
I have one question that is sort of taking us a little bit back to what we talked about of scarcity and abundance, putting it in the context of Peltarion, and then taking it home to the enterprise. So I kind of get what Peltarion is doing, like as a concept, but maybe we can take it. Maybe I don't know. I just want to go there. Let's be a little bit concrete. Like, so you're working with a big enterprise, and basically, of course, they have their super big legacy tech stack of a lot of different systems. They've had their sort of data platform project running since, I don't know, nowadays since 2013, 14, 15. So they have either an on-prem stack, or they've started to use Azure or Amazon, and then they started to play around. They are doing more data lake stuff. They're doing pipelines. They're doing a bit of warehousing and all that. Where does Peltarion come in? And if I think the whole life cycle from data engineering, machine learning, data scientist, deploying it from idea to deploy, where does sort of the toolbox fit in today? In this sort of enterprise context?
So it very much depends on the company, on how data ready they are. I can give you like two examples that are like two opposite extremes. One larger company, one a smaller company. So one is a large industrial manufacturer that, among other things, does industrial floor grinders. And one of the things with industrial floor grinders is that you really need to be an expert to use them, and there are a few experts. Now, so they had the idea of, can we, in some way, through vibrations, through sound, through something else, record how one of these experts does it, and sort of create a model that can then guide a novice user to use it. So what we helped them was like from ground up. We helped them design the experiment, design the sort of this. Put on microphones here. We actually had a couple of our data scientists, funny videos of them running around with the floor grinders. Really sort of recording the noise, and then we helped them build a model and so on. And the idea is over time, so this of course then deployed on the platform, and the idea is that Husqvarna over time will take over and do it themselves. So this is like a very gradual, we help them along.
So do they, but like concretely, do they live now in Peltarion's own cloud as a SaaS solution, or how does it work?
Basically, it depends a bit on the project. If it's simple like image classification or some of the text things, or things that's typical stuff that we support really well on the platform, then it goes on the platform. Otherwise, it gets queued in a stack on stuff to be added to the platform. So in that case, we make sure to prioritize that in the development, and then we deploy it then on the platform. The other example, sort of the sort of extreme opposite in the other end, and I always bring up this example because it's my favorite. It's a Swedish medical company called Sybase that create this probe for the melanoma detection. And they were a very early platform user, and their idea was, can they augment the probe data with image data? So that's basically you could, apart from measuring a birthmark with the probe, that you take a photo of it. So the combined data goes into a model and it comes out with a prediction. And it didn't work. Well, it did work. They got okay results, but nothing like that would warrant them seeking new FDA approval, and sort of the results weren't too impressive. And year after, sort of they started using the platform, we had a meeting, sort of check-in meeting, and we were like, okay, they're churning. There's no way. I mean, they didn't get what they want, but they seemed pretty happy. And they said, yeah, the melanoma thing, we put that on hold, but we discovered another thing. So there's a layer in the skin, that's a membrane that keeps crap from getting into the skin, into the body. And when that membrane is weak, people with allergies, they get eczema and sort of rash on the skin. And the only way to measure that membrane so far has been by doing a biopsy. And that was only possible on an area where there was actually a rash. Then you could measure it. What they discovered that they could, with their probe and our platform, actually measure it really, really accurately.
So they figured out a new use case.
Yes, completely new use case. Wrote a bunch of papers, and basically this is a major part of their business now. And now the sort of the cool thing, why this is my why I like this case so much, is that there is no way we could have come up with that use case. We had no idea that there was a membrane in the skin. Like, well, what?
Oh, so give it in the hands of the real guys.
Exactly. Well, they're not data scientists. They're medical engineers and general medical people, and they wouldn't have had the chance without the platform to solve it. So that's super. And then at the end of the meeting, they said, it was almost as they were working, oh yeah, we have another system in production. And that's they have this factory in Uppsala where they produce the probe, and the quality control has been done by a person looking in the microscope at the tip of the probe and then saying, this is okay or this is not okay. And then so what they did is that they bought a video microscope, connected to a computer, and then the summer intern, the CFO's daughter, built a classification model for quality control. And it worked really great, and I put it into production.
That's super cool.
Yeah, so that's...
we love skunk work, don't we? It's not skunk work. I mean, I don't mean like that.
I think so. Well, I think one way to phrase it is basically, I guess, if we can put AI in the hand of domain experts and commit to deploy, then I guess you will have a recipe for success, I guess, of AI, right?
Well summarized.
All right.
Cool, Luka. What's next in your life? What's happening coming months for you personally?
So right now, it's what's really exciting for us is that we're getting more and more users on the platform. It's really growing exponentially. So everything that goes with that, and seeing what
another exponential trend or trend.
Yes.
Oh, cool.
Seeing sort of what people come up with. That there is nothing as cool when somebody uses a tool you built in a way that you never thought it could be used.
Yeah, that's really fun. And if you were to recommend someone that you'd like to actually listen to on this podcast, who would you recommend to have us here?
So as a future guest, so it could be interesting to have somebody from industry, some CIO or something like that, who's more in the, or somebody who has a more of a whole company view and sort of views the challenges. I don't know, Gustav Söderström, perhaps from Spotify.
Good idea. Awesome. That sounds great. And if you have any more thoughts, just
let's figure out some industry people. I think that's a great idea, because now we've had people in public sector. We have had some super techie guys. Let's focus eventually on some more, in how is it to be a receiver of trying to adopt AI? Maybe also, I like the whole idea of a company that is not data tech native, right? I think that is very interesting to hear that story. Yeah, let's do that. Great idea.
Thank you very much, Luka. It's a pleasure as
absolute
usual.
Pleasure. It's very interesting
to speak to you. So thank you very much.
Thank you.
Thank you for having me.